Hi guys, welcome to the lesson. Today we have some exercise, and after that we have a new title. If you want, I'll show you now. And chapter 8.2, identifying symmetry of 2D shapes. First of all, let's choose together um, some examples about our previous unit. Okay, so if you remember in the last lesson, the past lesson, we had to learn uh, about hypotenuse, congruent shapes. What does mean congruent? What does mean hypotenuse? What does mean right angle triangle? Okay, let's start with first exercise. Which sides is the hypotenuse in each right angle triangle? If you remember, hypotenuse, it means if we have a right angle triangle, if we have right angle triangle, what was right angle triangle? It was the sum of triangle is interior angle is 180. All right, the sum of interior triangles. So there's we have triangle also, but at least one angle of triangle must be equal to 90 degrees. Okay, and for example, as you see, this one is also 90-degree triangle, right angle, or this one is also right angle triangle, and option B also we have right angle triangle. So that's why at least angle of these triangles is equal to 90 degrees. That's why these features, these shapes called right angle triangle. And what was hypotenuse? Hypotenuse was the opposite angle of this triangle. Opposite angle of 90 degree. Opposite of 90 degree is our the longest side. It's called hypotenuse. Okay, so that's why in option A, the opposite of 90 degree is AC. AC is longest side of triangle. That's why this side is hypotenuse. And option B, the angle of A is our 90 degrees. That's why opposite of angle E is DF, and DF is hypotenuse in this figure. Here also we have written, and the last shape, the opposite of 90 degree is KM. So that's why these sides called hypotenuse of this right angle triangle. Okay, and the others, this side, for example, adjacent side, opposite side. Okay. So in second question, if you remember, we have solved like this question. Please solve on yourself at home. If you have solved, you can send me, okay, by social lines. And a third exercise, there's we have two shapes, two triangles. Uh, these two triangles are congruent. What was congruent? Means like same, all right? Same angle maybe, or the same ratio, they are increasing or decreasing, okay? In this shape, in first figure, we have one angle is 95 degrees. So that's why we haven't, we don't know the third angle. Let's remember what was the sum of triangle of interior angles. We have written here. If you remember, the interior angle of triangle is 180. So that's why what's the third angle in this shape? 180 minus 62 minus 23 is equal to what was 95, because there is we have 60 and 23, 85, 85, there is we have minus 85, and there is we have 185, 180, sorry, 180 minus 85 is equal to 95. So and the third angle of this triangle is equal to 95. Our wider angle is 95. The opposite of wider angle is our longest sides. Okay, and here also wider angle is 95. The opposite of 95 is equal to 7.8 centimeter. That's why YZ is equal to where is YZ here? 7.8 centimeter. Okay, the second longest or wider angle is 62. There's we have 62. The opposite of 62, there's we don't know. That's why I'm writing here X. It's a noun. Okay, let's check the first triangle. The second wider angle is 62 in the second shape. The second longest side is in the first shape is BU, because as you see here 7.8, it's longest than this side, and this side U is a smaller of two sides. Okay, and so that's why we can say 6.5 is our second longest side. So X is equal to 6.5. What was the X? X was XZ. XZ is here, so XZ is 6.5. The last one, uh, if you want, you can write here also 62 degree, and the smaller angle is 23. What was 23? Opposite of 23 is 3.1. What was 3.1 is UW is 3.1. Okay, so write down the size of angles. For example, UVW, where is UVW? UVW is 23, and the angle of UWV is 62. It's 2, and the last angle is YXZ. YXZ. Its wider angle or biggest angle is 95. Okay. Okay, let's start today's unit. The chapter 8.2, identify symmetry of 2D shapes. What is the 2D shapes? What is the identifying symmetry of 2D shapes? Symmetry, as you remember, as you know, if we have this shape like this, for example, this shape is called square. Square. That's why square is 2D, and the rectangle also 2D. I'm writing here. Follow me, please. This shape is also 2D shape because it has got height, and length or width. That's right, with L, length and height. If our shape has got height and length or height and width, so this shape called 2D shapes. Okay, as you see here also we have square also our 2D shape. Sorry, Mr. Can you give us, for example, some guys maybe say tell me right now, sorry sir, can you show us the 3D shapes, for example? For 3D shapes we can show you, for example, cube. Okay, because in cube it has got volume, but in 2D shape it has only area and perimeter. Okay, what was the area? Height times length. What was perimeter? 2 times height plus length. And these 3D shapes has volume. Okay, that's why A, B, and C. Okay, so that's why it has got 3 sides. That's why it is not 2D shape. By the way, this shape is the example of 3D shapes. So 2D shapes has got only width and height, or length and height. Okay, so identify symmetry of 2D shapes. What is the symmetry? Symmetry uh, if you have got the paper, when you fold it, okay, for example, this one is paper. When you fold it, please check it with the fold with the dictionary. This paragraph is very important, okay, so that's why, please, if you don't understand, please check with your dictionaries at home. If you fold the shape along its lines of symmetry, one half of the shape will fit exact on top of the one other half. For example, this one is our paper, okay. When I divide by two the equal parts, for example, this part is A, also this part must be equal to A, okay. When you divide by two parts, if I can divide by two parts, so this shape's called symmetry. It has got symmetry, okay. For example, in how can I say in triangle, in equilateral triangle. What is the equilateral triangle? All sides are equal to each other. Also, that's why their angles are equal to each other. 60, 60, 60. Okay, because the interior angle of triangle is 180. That's why it's equilateral triangle. And how many, for example, symmetry lines of this equilateral triangle? When I divide by the sum parts, this triangle, if I take a same shapes, equal shapes, these called symmetry lines. Okay, it's two and three. 1, 2, 3. So we can say in equilateral triangle, three symmetry lines. Okay, when you divide by three, you can take a same parts, equal parts. In the future, we will see the examples of these terms, line of symmetry. Okay, let's continue from here. A 2D shape may have a line symmetry and it may have rotational symmetry. What does it mean, line symmetry? It's now I have shown, okay, line symmetry and rotational symmetry. If your shape, when you rotate, when you, how can I say, mm, rotate, or the sum of synonym of rotate is, what was that? I have forgotten now. Reflection, maybe, or falling, okay? When you rotate this shape, for example, 90 degree, this shape is square. When you rotate 90 degree, your shape is not changing, okay? So that's why this one is, for example, square. Here is A. When I rotate to 90 degree to right side, clockwise, okay, and A is came to here, okay, first, and the others, sorry, the sides are not changed. Am I right? That's why the rotational symmetry means when you rotate 90 degree, 180 degree, and 270 degree, and the last one is 360 degree. When you rotate the 4 times this shape, if your shape is not changing, so you have 4 rotational symmetry of this square. Okay, this rectangle has also 2 lines of symmetry. The rectangle is symmetry. One of the lines of symmetry is horizontal, the other vertical. Horizontal and vertical. Okay, you can use the dashed lines to show lines of symmetry on a shape. If you hold a shape along its lines of symmetry, one half of the shape will fit exactly on top of the other half. In the future, with the examples I'll show you, don't worry. This rectangle has also rotational symmetry of order 2, because when you rotate it, for example, to 90 degree and to 360 degree, your shape you will get a same shape. Okay, your shape is not changing when you rotate it to 90 degree and 360 degree. Okay, if it's not changing, so your shape has got two, how can I say, rotational symmetry of order 2. The order of rotational symmetry is the number of times a shape moves the same as its rotates through one full turn. So As we have worked examples, first one is for each of these shapes, write down the number of lines of symmetry, number of symmetry, number of line symmetry, rotational symmetry. Okay, so number of line symmetry, rotational symmetry. What was the line symmetry? Let's check it. For example, this shape. What kind of shape? Like circle. When you drive the car, you can see the street. First one is, sorry, I take it now. And the number of okay, the number of lines of symmetry. Two lines of symmetry. Why? Let's read that explanation. What was the lines of symmetry? Lines of symmetry. When you return, how can I say? When you turn or when you rotate the shape, if your shape is not changing, so this shape has two diagonal lines of symmetry. Diagonal lines of symmetry. Two lines of symmetry. Okay, and the second one is okay. Let's read that carefully. This sentence. What was this shape has two diagonal lines of symmetry. Two diagonal lines. Its first one is in 180 degree. 180 degree. When you turn the 180 degree, for example, this shape. When you turn the 180 degree, how can you turn it? For example, this point is A. Okay, this point is A. When you turn the 180, what was the 180? If it's right angle, sorry, what was the name of this straight line? When you turn the like this 180, you'll get it like this shape. Okay. The second one is 100. Sorry, 360. You get that same shape. You get the same shape. That's why two lines of symmetry. This shape has two diagonal lines of symmetry. In order to rotational symmetry, what is the rotational? Rotational. For example, in 90 degree, if you turn to right 90 degree, this shape, for example, how can you turn it? For example, 90. If our lines, if I want to turn to 90 degree, for example, like this, our shape is exactly changed, but we not take a same shape. Am I right? In which degrees we will take a same shape? 180 and 360. In one full turn, the shape will look exactly the same twice. Once after rotating it 180 and again after 360 degree, you will get the same shape. Okay. So, and a second option B, we have parallelogram. Okay, these two sides are parallel to each other, and these sides also parallel to each other. That's why this figure called parallelogram. There is no lines of symmetry. Don't forget, when you how can I say, when you fold the shape, for example, this one is paper. Okay, when you fold the shape, it's approximately you get the same like this shape. Okay, when you fold that, this shape, our shape cannot take a same or equal parts. You cannot divide by equal parts. If you want to divide by like these two parts from A, for example, this angle is B A, this angle is B. When you fold it, also you cannot take a same parts. Okay, that's why in parallelogram, always there is no lines of symmetry. Okay, don't forget. It is not possible to draw any lines of symmetry onto this parallelogram. And second one, the order of rotational symmetry. For example, in 90 degree, when you rotate to 90 degree this shape, when you rotate, okay, for example, this one is parallelogram and this one is our 90 degree. When I rotate this parallelogram, for example, approximately I get this like this shape. Am I right? So this shape and this shape are equal or the same or similar? Of course not. Of course not. So that's why in 90-degree, you cannot take the same or similar shape. In 80-degree, 180-degree, in 180-degree, we get a same similar shape. That's why in 180, we had a one similar shape. Okay. Also in 360, when you rotate 360, your shape is not changing and it comes to itself. That's why in parallelogram, it has got order two rotational symmetry. In one full turn, the parallelogram will look exactly the same twice. Once after rotating it 180 degrees and again 360 degrees. Okay, in parallelogram there is no lines of symmetry. Okay, when you fold it, for example, fold, please check it in your dictionary. Fold, okay. When you fold it, you cannot take a similar shape. Okay, and what is the rotational number? Rotational symmetry. When you rotate, when you turn 90-degree, for example, the line axis, so 90-degree, 180, 270, as we have 360, okay? So when you rotate 180 and 360, you get the same similar shape. That's why in parallelogram has two rotational symmetry. Okay, exercise 8.2. I want to show you some shapes for you, and please check yourself. If you don't understand, please you can look. Uh, you can again play previous lessons, previous minutes. Okay, so copy each of these shapes and draw on the lines of symmetry. Okay, symmetry. What is symmetry? It has got a definition. If you have got a shape, if you have got any shape, okay, when you divide by, for example, this one is shape, circle, okay, circle. If I divide by vertical and horizontal, if I get the same equal parts, so it has got the symmetry shapes. For example, in circle has got two symmetry shapes, horizontal and vertical. Okay, so in first one, what kind of shape, what kind of diagram? It is rectangle. Yes, rectangle means all sides are not equal, but two sides are equal to each other. Okay, so this shape is a rectangular shape. In rectangle, how many lines of symmetry? Lines of symmetry. For example, lines of symmetry. Can I divide by the middle of this rectangle? Yes, they are equal each other, of course, A and A. Can I divide by also here, horizontal? Yes, below the shape and above the shape are equal to each other. Okay, so in this figure has two lines of symmetry, and this shape, can I divide by horizontal? Sorry, pen is very bad. Okay, and this shape, when I divide by two shape, I get the same shapes, two same similar shapes. For example, letter F, this one. Can I divide by here? No. Why? Because we have there is different part and we have there is different part. That's why it hasn't got uh, how can I say lines of symmetry. No. Let's check the horizontal line. When I divide by horizontal, so that's why we are take the here the similar shape. Below part is equal to above part. Okay. So for example, this one, last one is all sides are equal. What was the name of this shape? It was square. Square. When you divide by diagonal, your two shapes are equal to each other. Yes. Okay, it's 1 and 2, or uh, these shapes are equal to each other. Or here, if we want to divide by uh, horizontal, you can take a same shapes. Or sorry, it was vertical, and then this one is uh, vertical. Your shapes are equal. So 1, 2, 3. Sorry, 1, 2, 3. Okay, in a square, three lines of symmetry. Okay, blah blah blah. And from for example, C, in C, how many lines of symmetry? For example, can I divide by here? Yes, horizontal. These side and these sides are equal, but vertically I cannot divide to same part. Okay, that's why in this shape only one line of symmetry. Okay, so how many minutes we have? Uh, with these questions, I want to continue for the next lesson. Please watch again. If you have questions, you can ask me, no problem. Okay, please listen and watch previous lessons, previous videos. If you got some questions, you can call us, you can ask us. Thank you for your attention.